Alrighty. So we got to talk about Project 2 solution today. Right? We did Project 3 and we got introduced it in the video from Monday. I remember my PowerPoint this time. Life is good. We got to talk about unit testing. Right? Is that about as far as we got? All right. So let's go over the Hangman game here. We do the PyCharm. It doesn't matter. Whatever version I'm using. We got the new one, but this one's faster anyway. So I should just be able to grab this here and hopefully it runs once we actually write the rest of the functions. So I think I might have had a typo or two in there. We'll see. Project, project 2. Maybe. Coffee time. Why there were two underscores there? That's weird. Oh goodness, sorry. I have a curly brace in there instead of a colon. Let's see. Those here. Oh goodness. Yeah, that was. Don't need that. It was pretty close, right? And that could just be a triple quote here. For example, gallows. Oh, it missed some of the spacings. I'm sorry? It gives you a string block here. And that's got to be a double. Is that one more? That's a little bit off here. That's fine. Oops. All right. Sorry, let me zoom in here. So, get word. Has the word been guessed? Has person been hanged? Display hidden word. Get letter guessed. Is letter guessed in hidden word? And print gallows. All the different functions we're writing here to make this part work here. So, let's start with them. Let's see. So, we should be able to do get word. Does this one work for me here? Create function get word. Awesome. Now, it's not done yet, right? We'll come back to it. So we wanted to get a 4-character long or longer word here, right? So we'll say word is nothing, and while length of word is less than 4, we'll say word is an input of either a 4-character or longer word. Eventually, we can return the word, right? As soon as you give me something long enough, we're good to go, right? Didn't do any other validation. We didn't check for spaces. It's kind of weird to have a space. I don't, whatever. It's not perfect. It's just a little example. So we can get a word, right? Then has the word been guessed? So let's go add this one in here. I like when it makes the function for me here. Given the hidden word and the letters guessed. So, oh goodness, that's a bad spot for it. Let's do it up here. I don't like it being in the middle here. So for this to work, every letter of the hidden word has to have been guessed, right? So we're going to loop through every letter of the hidden word. And if it's not in the letters guessed, you haven't guessed it yet, right? So we're going to say for letter in my hidden word, if the letter is in letters guessed, really if it's not in the letters guessed here then, right, you can return false. It didn't exist. You hadn't guessed it yet. You can't have guessed all of them if you didn't guess at least one of them, right? If we've looped through all of our letters and we didn't return a false, you must have guessed all of them. We can return true, right? Pretty quick check for us, right? So check every letter in our hidden word. If it wasn't guessed, false, right? We're done, right? And then has the man been hanged? This one's really quick too. Let's go and add that in here. Create a function. Why do you put them right in the middle here? That's fine. And this is just return number of incorrect guesses is greater than or equal to 6. Right? 6 or more. You should stop at 6, right? Because our loop will stop here, but again, we're defining it. So just in case I screw something up, we'll make it greater than. But equal 6 should probably fine. Greater than or equal to 6 is overkill. Display the hidden word. Let's go. I'm just going to do it myself here. Display the hidden word given the hidden word and the letters guessed. So we're either going to, what? Oh my goodness. Colon. There we go. We're either going to print the letter or a blank, right? So again, for every letter in the hidden word, we're not returning here, but if it's in the letters that we've guessed, we can print the letter. And now we want to change that ending character to probably just like a space. We're going to add some spaces here. And if it wasn't, then I can print an underscore and change that ending character to a space. Right? Wow, I'll be consistent with my quotes or apostrophes here. Right? So either print the letter because we guessed it. If we didn't guess it, print a space, the underscore. Right? Get a letter guess. Get letter guess here. Given our letters guessed here. Are we missing? There we go. We are missing that. Here we go. Thank you. No. No. Stop. Okay. So letters guessed is a list here, which works out nice because we can add to it. Right. So to get the letter that was guessed here, we'll go ask them to enter a letter. Right. So we have our guess. It equals nothing to start. And while now, if we want to make sure it's only a single letter, right, we can do this while the length of guess does not equal 1. Oops, sorry. I was just doing C++ earlier. They like curly braces. If it's not 1, we'll ask them, enter a guess. So guess equals an input of enter a single letter to guess, right? Eventually we'll get a single letter here, right? And then now we need to see if they've already guessed or not. Right? So really, while the guess is not 1 or the guess is in my letters guessed here, right? Then it would be side or left parentheses. Oh, yeah, thank you. Yeah. So if the length is not 1 or the guess was already guessed here, we will tell them they already guessed it. So it might be nice to tell them they already guessed it. So we can look here if guess is in letters guessed, print, you already guessed that. And then we're just going to keep on prompting again here until the length is 1 and it is not in the letters guessed because that will make my while loop false, right? If it is 1, that's false. And if it's not in the letters guessed, that's false. False or false, the whole thing is false. My while loop stops. Right. Then when we're done, we're going to take my letters guessed, and we're going to append the guess to it, because that way we get the guess in the letters guessed for next time around here. And then we can return the guess because we're still going to use that guess just in a second here, right, what that single letter was. Right. If you didn't add it here, that's okay. You could add it down below. That's not going to matter. We didn't slice the list. So when we pass a list here, we're saying, here's where my list is. You can go append and remove from it, right? And it's mutable here. So we can modify it here in our function that we've passed it to, right? And then we have is letter guessed in the hidden word. This one's really fast. So I'm going to define is letter guessed in the hidden word, given the guess and the hidden word. You just return guess in hidden word. Right? That's just a one-liner. Works out nice. But again, we've put a name to what we're doing. I don't know if it's actually that helpful to say if it's not in, but that's okay, right? It's all right. Then print gallows. Find print gallows. Given the number of incorrect guesses, I'll just copy that. Now, there's a couple smart ways we could do this here, where we've got like if checks inside of what we're going to print here, and like if it's greater than or equal to 1, we print this one. If it's greater than or equal to 2, we print. That's really obnoxious and complicated, so I'm going to do it the lazy way. It's a lot of code, but that's okay. So we'll say, hey, if my number of incorrect guesses is 0, we're going to print. Now the triple quotes are nice because you can just drop a triple quote in a print, and it will print out exactly that. Here, I thought Zybooks showed that. My apologies if they didn't. Like, yeah, and it's just a single. You don't have to print every line with all your new lines and stuff like that here, right? And then elif my number of incorrect guesses is equal to 1, then we're going to print just the head. Elif my number of incorrect guesses is equal to 2. Print head and the body, right? Elif my number of incorrect guesses is 3. Oops, sorry, that's going to go down a line. We're going to print the left arm. Elif my number of incorrect guesses is 4. We're going to print both arms. elif, my number of incorrect guesses is 5. I'm going to print, oops, everything but the last leg, and elif, my number of incorrect guesses is 6. We're going to print the whole thing. Oops, parentheses. Just when I paste, it does it by itself because it knows where the alignment is. So I'm just hitting paste right here on the gallows. Oh, it's just when I hit enter. It did it for me. Hang on, where's the parenthesis? Come on, parenthesis. There we go. So it thinks it's part of this still, but if I type elif, it recognizes that elif is going to be chained to the other one here. So uh, test equals something here, and I just as soon as it hit the colon, it tabbed it in for me. So I wasn't doing anything there for that one. But that's it for that function. It prints the gallows, right? Again, a lot of repeat code here. I don't even feel that bad about it here. You know, maybe, but it's going to be really ugly otherwise. To like, if you want this, and I don't know. But up to you, right? You could do one line at a time, right? So this line happens if it's one or more, and then this line would need 3 different checks, right? Either it's 2, we have just the body; 3, it's the body 1 arm; 4, it's the body in 2 arms. Sure. Again, whatever. However you want to do that, it's okay. But I think now it ought to run. Let's give it a try. So what word should we guess? How about dog? Oh goodness, I spelled an extra letter there. I want to make sure that it worked for short. Right, so it wasn't long enough, right? All right, so what word should we guess? With an H. Okay. All right, enter a single letter to guess. A. Oh, we got a head. G. All right, how about GH? Oh, a single letter. O. We got the OG. A. I already guessed that letter. The check's working well. H. D. I didn't tell us we won. Maybe we could add in something like that here. Sure. I don't know. If you want it, cool. If not, or tell them what the word was, but we already entered the word, so it seems a little silly to do that. Yeah, let's Hangman with functions. Again, it's one way of defining functions here. Definitely not the only way, right? Tons of different ways of solving problems here, right? So again, it makes this relatively short here in the main section of our code. And I'd like to imagine the functions are named well. I mean, I picked the names myself, and they're pretty descriptive here. Right, so it's nice. Oh, the parentheses here is what's extra. It keeps yelling at me here. There we go. Right. I think it flows relatively well. Okay, now it added parentheses. That's fine. Right. So again, we have nice names to what's happening. All of our variables have decently named names, I'd like to imagine. So we can look at this and know kind of what's happening without having to do a lot of work. And if we care, then we can go look at the functions and see what the functions are actually doing here. Up to us. That part make sense? All right, awesome. Let me go commit that here before I forget. Step 1, 2. Oh, and then I forgot to grab the code from last time. So let me go grab that here. So we did our classes here. Let me drop that over to the next semester. Look at that, rinse and repeat. 603 items. Holy cow. Oh, it's the virtual environment. It's the big part here. That's why. All right. So let's go open up and pick up where we left off here then from, oh goodness, I gotta go find my documents. GitHub 1501, 2025, chapter 9, classes. Oh, I named it by chapter, not by week. That's obnoxious here. But we've got our chair. And we did the chair. Yes. So we had a lotto ticket with numbers. Get numbers. If it's a winner, giving another ticket here. Now, we didn't really have a good way to test this, right? It's sort of the problem. And the idea of writing unit tests, I asked you to do, but we didn't tell you how to do them yet. So let's talk about unit tests. So how would we test this aside from writing a bunch of code here and seeing what outputs, right? Have you guys ever written an English paper and read it yourself and then missed the fact that you put the word we twice? Because when you're reading, you're like, oh, I know I just said we, so you don't notice it says we. Or anytime you repeat words here, we're bad at that sort of stuff, right? People are actually really bad at checking output because we know what it should say, and we're going to miss sometimes that it doesn't say what we think it's supposed to say because we know what it's supposed to say. We wrote it. Of course, it's going to do the right thing, but we have mistakes. So, you know what's really good at checking if output matches? If something matches what it expects? Computers. Yeah, computers are good at that sort of thing, right? So, we're going to make the computer do the testing for us. And the fun part is we're going to write code to do that. So, we can write code that tests our other code. Which is a lot of fun. We'll call it unit testing. There's levels of testing. There's unit testing. There's integration testing. There's system testing. There's end-to-end testing. There's user acceptance tests. All sorts of things. Go take the software engineering class. It's fascinating. Um, I happen to enjoy testing. That sort of thing. There's a really funny T-shirt here. Oh, the engineer T-shirt. Hang on, let me find it for you here. Yeah, this one. This one. That wasn't it. That was not the picture. That was the picture. Shoot. Where'd it go? Oh, hang on. Engineer. Into a bar. This one here. All right, it's a little small. Can I make it bigger? No. View the image. That's a little bit bigger. So quality assurance tend to be the people who make sure that the software does what it's supposed to do. I mean, for anything, but specifically for software quality assurance, they test our software. And one of their jobs is to make sure it does what it's supposed to do, and also that it doesn't do what it's not supposed to do, which is much harder to test. Right? It's very easy to be like, okay, if this goes in, this should come out. But what if I put garbage in? Does it break? And that's the sort of thing they tend to be good at here. So you order percent beers, 9999.99 beers, negative some number of beers, null beers, blank beers, something else here. I don't know what it is. And then the joke here, the next line is, all of this passes here successfully. We give nice error messages, and then they walk into the bar and order a water, and it starts on fire because we only set it up to order beer. Uh, uh, but quality assurance testing here is fantastic. So we're going to write code that tests our code here. So for lotto number, what we want to test is, does my winning actually work here? Right? Can I get 2 tickets here, say that they matched without having to generate them here and look at the output and say, okay, is it a winner? I returned a true or printed a true, whatever it happens to be here. Not a very interesting test. Chair is slightly more interesting here because we protect the height. We make sure our height doesn't go below minimum or above max. Okay, so we'll test them both here. So to do that, I'm going to come to my class here. I'm going to right click and say go to test. And PyCharm says, you don't have any tests. Do you want to make new tests? And you say, yes, please. So yes, make tests. It says, oh, how about a new file called test main? Sure, I like it. What do you want to test? And I want to test is winner. I'm going to check that box here. So defaults are great. It will do all that other stuff for me here, and it makes a new file here, and it automatically adds some imports for me. So we've got a library called unit test, and we use test case. Now, this syntax makes no sense at all. That's okay. We'll get here. This is using inheritance. We'll get to what that means in a few weeks here. Don't worry about it. But for now, just assume it's magic. A couple things to make the magic work well. The class needs to start with test, and our functions need to start with test. Okay, just keep that in your back pocket. Not too big of a deal here, but weird stuff will happen if we don't name them in the way that it expects. So testing is very convention-based here, so we have to follow the conventions. And we don't want our test to fail. Right? So what we're going to do is we're going to do this AAA convention. Is just a way of laying tests out. Convention here. So we're going to arrange, which means we're going to set up stuff we need to test. And then we're going to act is call the code we're testing. We see, I did it already. I can't type English myself here. Testing and get results. And then we're going to assert, did we get what we expected? Right? So again, you don't have to do them in this order here, but if everybody lays out their tests the same way, we follow this convention, it makes it easy to look at other people's tests here. Right? So we need a ticket and we need a winning ticket. And we need to know, did we expect to win or lose? So this is test is winner. I'm going to say is true here. And we'll also do another test where it's not true because I want to make sure that they work, right? It might be a little overkill, but that's okay. We'll get there. So I'm going to have a ticket so I have to go import my ticket. We didn't get to modules yet. It's all right. We're jumping a little bit here, but we're going to say from main import lotto tickets. No? No, lowercase main. Sorry, that's why. Import lotto ticket. There we go. So it's the name of the file. And we'll get to this in a little while, but files are modules. This is the class name. Yep. So lotto ticket's the class name. Main is the name of the file itself. Files are modules in Python terms here. So we're importing that class. So now I can make a ticket. So it's a lotto ticket here. And then lotto ticket wants 3 numbers, right? It should have given me that. That's sad here. 1, 2, and 3. There it goes. Now it's suggesting it. And then we'll have a winning ticket is a lotto ticket given, how about 1, 2, and 3, right? And then we're going to have an expected result here then. We'll say is true, right? We expect this to win, right? So this is the value I expect to get back here. So to call the code we're testing, we'll have the actual result is my ticket dot is winner given the winning ticket. And assert, did we get what we expected? So we're going to say assert dot, assert equal? No, hang on, sorry. Assert equal? Equal? Oh, my self dot, there we go. Self dot assert equal. There we go. It just takes a second for the brain to kick in here. So what do we expect to be equal? Well, I expect my expected result to be equal to the actual result, right? And this self dot assert equal, it's going to go check it itself because we get a bunch of cool stuff from the test case class that knows how to do these sorts of things here. So now what I can do is I can click the little run button here and it will run the tests for me. And it will tell me in this really cool looking test explorer if they passed or failed. And I say, oh, this one passed, right? So I'm just going to copy paste this one here. We want to do one test is false. Oh, we should say is loser, right? That's funny. Test is loser. And then it is winner. There we go. So if it's 1, 2, and 4, then my expected result should be false here. And let's see what happens. So now I'm going to come back and run my tests. You can run them all. You can run just the one here. But winner and loser pass. That's what we expect. So I can have code that tests my code and make it run here. And I can run all the tests. So this seems like a lot of extra work here. But when we think about software, right? Software engineers get paid a lot of money to write software. So companies who pay that money want to get a return on their investment. They want the software that they paid you a lot of money to write to be used for as long as possible. Because every time they use it, ideally it's making them money or making them more efficient or whatever reason they wanted that software, right? So they want to keep on using it and keep on using it, keep on using it. So the longer software is used, the more return on investment they get. So software tends to exist in this maintenance phase where it exists, and every so often we have to make small little changes to it. Right? Oh, it'd be really nice if we had this new feature or something changed, we have to tweak something. So software is maintained. As we maintain software, we can run unit tests to make sure we didn't break anything that was supposed to work. Right? So if we put tests in our code here, I can quickly just run all my tests and make sure, oh, I made a quick little tweak here. Hey, the tax changed. Now it's a 7% tax instead of 6% tax. Sure, let me make a little change here. Did anything else break? Right, so it gives us a way to run our tests and make sure that we feel pretty good that we didn't break any behavior that already existed here as we're modifying and maintaining our software. Yeah. Yeah. Yeah, so we could add in like, hey, define is winner regardless of order, given a winning ticket, right? And that's just going to return, do the 3 exist in any of the other 3, right? So instead of saying, does 1 match 1, does 2 match 2, does 3 match 3, we'll say, does my 1 match 1, 2, or 3? Does my 2 match 1, 2, or 3? Does my 3 match 1, 2, or 3? Right? Again, it's probably easier to just use lists at that point here, but so we'll say, I don't know, numbers equals a list of self dot number 1 self dot number 2, self dot number 3, and then winning numbers is a list of winning ticket dot get number 1, winning ticket get number 2, and winning ticket number 3. And then we can return numbers dot inters intersection. Is that what it is? Union and intersection. The intersection is only the common elements here. Yes, I want the intersection. So that is a set intersection on another set. Okay, so they can't be lists. They have to be sets. Set of that and a set of that. I think we really briefly looked at sets way back when. Does that ring any bells? They had to be unique, so no repeats. That might make this a problem here, but again, that's okay. We're just going through an example here. Let's say numbers dot intersection of winning numbers, and we want the length of that equals 3. All that work to avoid 3 different loops or 3 different, like, 9 checks, right? Does this number match these 3? Or maybe this is fun, maybe not. Why does it not like it? What does it not like about this? Oh, it's not literal. There we go. Oh yeah, as the dictionary syntax. There we go. Right, dictionaries without keys are sets, right? Essentially. There we go. So, sorry, values. My goodness, I need more coffee today. Thank you. All right. So anyway, we could change our code here, and our tests still exist here. We can still run all of our tests. They still all do the same things, checking the existing behavior, and then we can add in the new behavior sort of stuff here, which is fun. Uh, Lotto ticket's not the most interesting, but let's test the chair class because that's more fun, right? We care about the change height because it should change the height in centimeters, no more than the max, no less than the min. So we can test those different values here as we go. So I'm going to right click the class name and say go to test. It says, yeah, let's make some new tests, put them in main. I want to test change height here. Now, the set and gets are good to test. So it is, we want to test all of our code here. So we want tests to be small. You want to test 1 unit at a time. Testing every single get in different tests feels really obnoxious, and I don't like doing it. So I usually just do a single test for like tests init, uh, and then I can arrange, I can act, and I can assert. So I need things that I'm going to test. I have a color, I have a has arms attribute, right? Now this one also, I want to change my set color. I want to use set color. So if I use set color here, self.setColor to the color, I don't need to test the set separately. I'm just feeling a little lazy. Um, so I can have an expected color is blue, and an expected height is, I don't know, what, 30 centimeters or something here, and an expected, I guess, has arms is true. Right, and we'll go make a chair. So we're for testing the init method. That's the one we're acting on here, right? So we're going to go import chair as well. Sorry, main import chair. There we go. So we can make a chair equals a chair given, what does it want here? It wants the color, so my expected color, and oh goodness. Oh, it doesn't have has arms here. Oops. Do we not do that one? I never finished that one, sorry. So we'll just forget it then. We don't care about arms. Do we have a height? We don't have a height either. Okay. We didn't pass in very many of these things. I'm sorry. I guess we want to go, let's go change that. So let's do has arms here and a current height. I can go change it, right? It's our code. Right? So we'll go back. We'll get our has arms, expected has arms, and the expected height. Now we should also pass a minimum and a maximum then, right? So we should have an expected min height was 10 and expected max height is 100. If your chair goes up to a meter, that's like a stool at that point, right? But sure, why not? We'll have an expected min and an expected max. Let me just go add those in here as well. So we'll have a min height and a max height. I feel bad not spelling out minimum now. Minimum. There we go. I always complain about that. So my min can be the min, max can be the max, max height. There we go. And has arms can be has arms. And my height. Now, do want to do this only if it's within range, right? If they give me a bad value to start, we've done a bad thing here, right? So maybe then go check to change height here, or maybe we'll call change height. Maybe we started it at 0 and then we call change height. Change height given the current height, right? Because that way all that sanity checking we did should work, right? To make sure we don't go below the min or above the max here and make sure we stop at one of them. So I kind of like that idea of using it here. Well, so I set it to 0, and then I'm calling it to go change it. So 0 plus your current height. Oh, we got to set the min and max, is what you're saying? Yeah. Good idea. That would cause some problems here. Thank you. I was too excited to answer the question. I didn't listen. Let me drink some more coffee. Yep. Good catch. All right. So now we've got all of that. So we should be able to pass it all in here. And now we'll go get our actual values here. So the actual color is my chair.get color. My actual has arms is my chair.has arms. Sure, I guess we didn't make that one private, so we'll just go get that. We didn't use a, usually we'd have a function here. And then an actual height. Height is chair.get height in centimeters. There we go. I don't think we added methods for min and max or functions for min and max yet. Now, writing all those set and get methods are really annoying, right? Having to have sets and have gets. And it's all the same thing every time because we generally want our attributes to be private. It's a good practice here because you don't want someone to go change these things outside of your control. Because if they go change the height in centimeters and they put it at 10,000, we've done a bad thing, right? Classes should protect their integrity. So I'm going to mark all these ones as private here. Oh, actually, let me go rename. I'm going to right click, refactor, rename, and have my underscore. That way it renames it everywhere for me. Oh goodness, that was not the button I wanted. Right click, refactor, rename, Shift F6. What a weird shortcut there. Shift F6. And let's go to refactor, rename, has arms. Now, did it do it here? It didn't. Oh, it did. It renamed it here. Which you can go get private variables. You should not go get private variables. Right? It's just considered bad form here. So we want, I don't know. We'll come back to that in a second. So back in here, writing all the gets and sets are really annoying. No one wants to write all of them. And it turns out developers who wrote tools for developers, like PyCharm, gave us shortcuts. So we have the generate menu. This is my favorite menu. No, where is it? Implement methods, override? Oh, does it not? It does it in Java. Really? I wonder because this is the free version. I think the paid version has the generates. It would write the code for you. Uh, let me check. Let me check here. Um, Full version. Maybe this one has it. The lamest thing to not have. Right. Set functions. And setters. Really? Does it not have it? Doesn't have it. Okay, code. All right, it doesn't have them. All right, I am just misremembering here. That's obnoxious. We can write them. I don't even want to write them here. I'm going to do this here. Let's go over to UMGPT here, and let's ask it to write it for us here. Write, set, and get functions for the attributes of this class. And I'll paste it in. Yeah, it's even writing what it thinks it should be. That's not a very good test, though. Get maximum height, set maximum height, if you wanted, right? Setters and getters, get height, set height. Ooh, making sure it was valid here, right? Look at that. Has arms, get color, set color. I think we already did the colors here, so let's do the copy from here. Now, this is a very helpful comment here because I wasn't sure if you would recognize that these were getter and setter methods for height. That's so obnoxious when it does that. But we asked a question here, so I'm going to come up here and cite my source, and we'll do a comment. Can I do a comment block? What do I do? That one here. And this was UMGPT. There we go. That's what I asked for. Here's what it gave me. So we already did a set height, didn't we? Oh, we did change height. So we don't want a set height. We can get rid of that one. Do we have a get height? We have a get height in centimeters. We already had that one. Set minimum and set max. Now, once your chair has a min and max, I don't think those change. So I'm not going to do the sets for those. I'm going to leave the gets, right? If it shouldn't change, you don't add a set for it. Like color can change. You can paint your chair. You can reupholster your chair. You can't really change the number of legs on your chair. Doesn't work very well, right? So things that don't change, we don't add sets for. Things that do change, we do add sets for. So gettings, right? Gets, so set color, good. You got those ones. Get has arms, set has arm. Oh, that was part of that one here too. You could probably take the arms off your chair. Does that one seem fair to be able to set has arms true and false? Maybe? Sure, why not? So let's do that. So we'll say set has arms given has arms. Again, just to use those same ones here. All right, all that now, so I can do my get method. So this is has arms is chair dot set. Get has arms. There we go. Now I have a function for it. Get the height. We could get the others here. Actual min height. Chair dot get minimum height. Oh, that's max. Get minimum and an actual max height. Chair dot get maximum height. There we go. So we got a bunch of values. Let's go see, did we get what we expected? So self dot assert equal my expected color and my actual color. Now, just for a second here, I'm going to change this expected color to black, just so you can see what it looks like when it fails here. And then self.assert equals my expected has arms and my actual has arms. Self.assert equal my expected height and my actual height. Self.assert equal. So it's a little tedious to do some of these here, but not too bad. My expected min height and my actual min height. Because believe it or not, I typo these things more often than you'd imagine here, even in something simple like an init method. Min height should match the min height, and sometimes the type ahead gives me the wrong one and I don't even notice. So, yes, it seems annoying to have to type a bunch of stuff to test the things we just wrote, but it's worth checking, right? Any code that's worth writing is worth testing that you did it right. Because if you don't care if you did it right or not, don't write the code. If it doesn't matter if it works, you shouldn't even write it at all. Right? If it matters if it works, then yes, it's worth doing, it's worth testing. So we're going to test all those out here. And then the actual self.assert equals my expected max height and my actual max height. Now, this sort of stuff, the Intellus, the super completion in the newer version is really good at doing. Yeah, it'll just be like, hey, you're testing this, I noticed here. Now, again, though, you got to look at it and make sure it did it right because sometimes it does weird things here. You get some weird results occasionally. So, but let's give it a try. Let's go run our test chair here. No tests were found. What? That's not true. Test chair. Test init. Test. No, that's not true. Rerun. Can't rerun since test IDs can't be resolved. Delete run configuration. What? Is it because I did two different tests? All right, hang on. Let me pull all this out for a second here. And let's go add a new test chair here. It might, just because I put two classes in main, I think I might have screwed it up here. Let me try this now. I think this will be happier. Seriously? Oh, that's a different error. Chair. What? Chair. Oh, this one's failing now. Oh my goodness, that's why. Okay. Goodness gracious. Yeah. Okay. Let's default them here. False, 30, 0, and 100. Okay. Now this so one and I included it stuff I didn't get to yet. I broke it. Now will it run? Hey, okay, it runs, but they fail. So I'm getting red X's or kind of orangey looking X's here. It says blue does not equal black. You expected blue. It actually was black, right? And you can see right at your test line 25 is where it failed here, right? We did that one on purpose, right? This should be the expected color, right? And now I can rerun my tests here, and now it passes. So we get that. So you can see if it fails, where it fails at a specific assert here. Now change height fails because it just fails. We didn't actually write any code here, right? So we want to go arrange and act and assert. So this is change height. I don't know, just works, and then we'll do one won't go below min and one won't go above max, right? So we don't need all of these things every time here, right? So I'm going to make a chair. A chair equals a chair. I don't care what the color is, right? So I can just give it that. I don't care if it has arms or not. Doesn't really matter, true or false. Now, what does matter though is the expected height. Right? So I need an expected height here, but really I'm going to have a starting height and then a changed height. Right? So I'm going to have like two different values. So I'm going to have a starting height is, I don't know, 30, and then the expected height is 40. We'll see if we can go up or something like that. So we'll have the starting height, and we'll go 0 and 100 for the min and max. I don't know. We can go back and change those later if we want here. Or we can just code, I guess we can just code in 30. It's not the end of the world here, but otherwise we could do some arithmetic. So we've created the chair. Right now we're going to act. We're going to chair.change height, and we want to change it 10 because we want to get to our expected here, and then we'll have an actual height. Chair.get height. And we can assert self.assert equal my expected height and my actual height. Right? Again, lots of ways to go about it here. It's okay. Some people just hard code their values in the expecteds too, right? Or you can put these function calls in your actuals. I like putting them all here. Um, I don't know. And when you run it in debug mode, you can pause and see what values are. Sometimes that's helpful. It's harder to pause when you're doing function calls, but it's all right. So this one should work, and it works, right? So I'll copy paste all of it here, and we'll have a test stops at max, right? So if we go up by 100, right, we should stop at the max here of 100, right? 30 plus 100 should stop at 100. Oh, let's go up like 1,000, right? It doesn't really matter here. It should stop there. And then we'll test, excuse me, that it stops at the min as well. Stops at min, right? Let's do minus 1,000, should stop at 0, right? We can run all of our tests again. I got to run them all here. Nope. Come on. Is it this button? That button. There we go. So sometimes it gets a little confused. You just have to kick it. I don't know why, but that ought to be fine. So now all my tests pass here. Let me go put these back. I think we can put these back in the other file here again. Let's try it real quick. Let's test main, put it in the other file, and see if these ones all run. Okay, cool. So I can get rid of test chair. That was just the other problem. So we'll delete that. Test main. Should be able to run all of our tests. Get test chair. and test Lotto, run tests. No, Lotto works, test chair works. So we run our tests. We feel pretty good. So if we've got testing here, the next thing we can do is continually test our code when we change our code, not on my machine. So unit tests are made to be fast. They're supposed to be fast, but as code gets bigger and bigger and bigger, you'll have more and more tests, right? With lots of people working on it, you'll get thousands and 10,000s and hundreds of thousands and millions of lines of code, depending on the kinds of projects you work on. Running millions of lines of codes of testing here is going to be slow, and you don't want to pay someone to sit around while their computer does a bunch of work, right? So what you can do is you can make someone else's computer do that work. And turns out people using source control tools to trigger that is generally common because you'll take your code and you'll commit it to your source control tool, and from there you can go do something. So GitHub and lots of other hosting tool providers here do stuff like that. So this is VS Code's library here because it's a fun example. So every time code is committed here, one of the things GitHub sells, right, it's a service they're selling, of course, is it can run continuous integration tests. So as code is integrated into the code base, right, when you commit your code, it will can run the tests on it. So you can see, hey, 14 out of 18, 28 tests passed, and you can actually click on it and see which ones are passing. Oh, these ones are still running right now, right? These ones passed, right? And you can go look at the details and all these sorts of things. So if we can make code to test our code, you can write code that runs the test code for your code when your code changes. It gets a little bit crazy here, but it's fantastic, right? So that it's essentially a virtual machine in the cloud will go and run those tests here. I don't have to do it on my machine. So if I've got big long tests here, I'm going to check it in, and then it can run all of the tests. You can set it up to run different layers of tests and all sorts of really fun stuff. This is more the like DevOps style stuff, which is really fun. And then if you feel good that your tests cover everything, and you feel like, okay, if all my tests pass, I should be able to go give this code to my customers. The next step is continuous deployment. So we can have continuous integration testing and continuous deployment. We call these things CI/CD pipelines because everyone loves their letters, continuous integration, continuous deployment, and you build pipelines. So in uh, GitHub, they're called pipelines. There are other tools. You can, a bunch of things will run stuff like that. But a site like khanacademy.com, I've got some buddies who work there. Every time developers commit code to their site, it will go and update the site live. So dozens of times a day, khanacademy.com or .org updates. The reason why that's helpful is the shorter time it takes a developer to write a feature and to get it into the hands of the users, the more productive they are because you still know what you just did and someone can go test it for you right away. Be like, hey, you had an idea. I'll go write it here. Now you can go test it. If I had to like package it up and give it over to a quality assurance engineer and they had to add it to their queue of work for the day, and maybe they got to it that day, maybe they got to it the next day, and then we had to send it to a release engineer to go and update the website, and they had to schedule some maintenance and take the website down for an hour, and all sorts of other stuff can happen, right? But if it takes a week for me to write a change, for someone even to go test it, I've forgotten about it because I've done a bunch of other stuff already, right? And then they're like, oh, you got it 90% of the way there, but what I really wanted was this instead of that. You're like, well, you should have told me that the first, but whatever. We'll go back and fix it because you're the one paying me. That's fine. You have to like reload all the stuff you're doing in your head, get back into what you were changing and go change it again. Versus if it can take me 5 minutes to do it and they can test it 10 minutes later, right? The workflow is much better. We can be more productive, which is awesome. It's hard to do for every application. Not everything we can update live. Not all of our customers want us to change their software all the time here, right? It depends what we're working on here, but websites tend to be really good at that sort of thing because you can just update your website. And now the next time someone hits it, they have the new version.
That kind of stuff was mentioned about.
Uh, that was their infrastructure itself. So that was their network monitoring tool was screwed up, so it like took stuff offline. I don't know if they ever finished their whole uh, update of that. But if Amazon stuff goes offline and you use Amazon tools, it breaks your stuff. Um, yeah, but someone updated something and it wasn't tested well, I'm assuming, or I don't know exactly what happened where. But we can do all those tests, get it all set up here. You don't have to do continuous deployment, but it's nice to do the continuous testing at least here, and it's nice to not have to run it on your machine when you get larger projects. That sort of stuff is really cool. So this is very common to have continuous integration testing because we use tools like GitHub or Git. It can work on any vendor who has a tool for Git has the continuous testing stuff you can hook up and configure. It just runs all the time. And that's why conventions are important. It's like, hey, go through and find everything named test and run everything named test. Right? It can scan the code itself to see what tests it needs to run very quickly. You don't have to like give it a list of things. You're like, if it's named test, run it, which is usually makes a lot of sense. You don't name real stuff test very often, right? Unless you're writing test banks for like educational software, and then it really screws stuff up. But that's okay. Um, that sort of stuff is really fun. So we can write tests. One of the things, so this one I don't think does it, but I think the paid version does, is you get this idea of code coverage. It says how much of your code is running when the tests run. Right? How much of your code is covered by tests, right? And it's a metric. It's something you can measure. Again, paid versions will do the sort of thing for you here. So like I never tried string. I didn't test string. So I don't have 100% code coverage. For us, we're just going to eyeball it and be like, okay, I know I ran this function, but if I don't test that I went above the max, this line of code never runs. If I don't test I went below the min, this line of code never runs. That's why I have 3 different tests. I tested that change works, I tested that you stop at the max, and I tested you stop at the min because I wanted every line of code to run at some point when my tests run. Right? If I just stopped at hey change works, I don't know if these work, right? They should, but I never tested them. So I don't have 100% code coverage. So we're just eyeballing it here, and we don't have that large of code here for your shopping cart. You don't have 1,000 lines of code you need to go look at. You're like, okay, does this function all my if else's? Did I cover each of those essentially here? Um, did I test my sets? Right, that happens when we test our init. Essentially, it works pretty well because I used them here. You could go make a separate test for set color. It's just really boring and tedious, and I know my init method does it because I make it that way. That's all. Excuse me. So when we're looking for test coverage here uh, in the next assignment, right? Write unit tests for item and shopping cart. So part of your points come from having the unit tests for them here. So with item, right? Sets and gets, sure, that's fine. But get total price is the important one here. Does this one work here? Right? And we can test string. Does it give me the correct looking string output? Right? We can do that. This sort of like letter for letter, do the spaces match? You'll be very familiar with all your SciBooks exercises, right? When you write your unit test, it's going to check letter for letter, space for space, does it match your expected output, right? And that's actually how they do it behind the scenes. They write tests behind the scenes for stuff like that with SciBooks. And then for shopping cart, it's my receipt here, really, that works. Adding an item, sure, it adds, and then now the receipt will show that item, right? That's the way I know add works. So really, we don't need to test add separately. We just need to test that the receipt shows all the things we did add, right? So probably need at least more than one item to make sure that the grand total works, right? So like add 2 things, do both show up on the receipt and the grand total? Great, life is good. That sort of thing for the unit test. So they don't need to be super long here, but that will get us to 100% code coverage, right, for those things here. Shopping carts don't have names. Maybe at some point we could extend this and be like, okay, here's my Meijer shopping cart, here's my Target shopping cart, here's my Amazon shopping cart, here's my GameStop shopping cart, and have a bunch of different shopping carts. We don't have that right now. But at some point, that's the sort of thing we could do with our software, add to our classes that we're writing, and do cool stuff with them. That part makes sense? All right, awesome. I think that's all I got today. We're done just a couple minutes early. We'll come back Monday for more new stuff. Did I add the Zybooks yet? I don't think I added the Zybooks assignment for you yet.
Thanks.
So that is chapter 9. That'll be due next Monday. 9 due at the end of Monday. That one you don't have to turn anything in. No submission. Right. Yeah, I think, and I'll score chapter 8 that was due. Oh, we didn't have anything due. That's right, because we didn't have anything last week. So uh, I offered. I don't remember if I told you guys. I'll be happy to rescore 1 or 2, 3-ish chapters. I don't want to rescore them all for you. But if you just didn't get one done and you want me to rescore it because you got it done a little late, I'd be happy to do that. Like, the goal is you do it, and then you get the points for doing it, which is really good because I know how it works. If there were no points attached, I just didn't do it. Right? Because why bother? I get it. So if you want to rescore, just shoot me an email. I can go rescore any of the ones that you might not have done well on. But let's try to keep it to 1, 2, or 3. Okay. All right. Awesome. Thanks. I will see you folks Monday then.